Good morning. I'm Andrea Ragazzi from Leonardo Helicopters. In Leonardo Helicopters, I'm simulation technical lead. The presentation I'm giving is our view and experience on a certification basis on certification based on simulation. The presentation is this is the summary. Is split up into three sections. The first one is our view, what we want to go on certification by simulation. Okay. The second section is about our experience on certification by simulation so far, and the third one, the last one, is the first step we took to fulfill our to reach our view. That is the RoCS project. That is the core of this workshop. So we start with the first part. That is our view on certification by simulation. I think we should say that rules already allow for the use of simulation in certification. For example, this is what the test guide for certification of transport category airplane says on the benefits of simulation, and specifically when simulation is an alternative, a viable alternative to flight testing. So the first one is when the test is too risky, even if when, for example, I perform some rehearsal in mild air condition, some tests might still be risky. An example that I'll show you later is the power of landing. The second one is when environmental conditions are difficult to attain. So, for example, simulation of wind, gas, or particular offshore scenarios when it's difficult to get there, high altitude conditions. Third one is a repeatability effort. So, for example, when we need to assess the same maneuvers, for example, in inequalities, through a range of pilots, using a range of pilots. From a company point of view, we think that the three main advantages of simulation, there are three main advantages of simulation that I will present through this graphical representation, the advantage triangle that was presented the first time in an engineering conference we had in Liverpool. In that paper, the first advantage is for sure safety, and this advantage couples with what already shown by the rules. So we can substitute by simulation some risky scenarios. The second one is the effectiveness. So we can basically get more understanding of what we are simulating, through changing the conditions and the configurations more than we can do in flight. And the third one for sure is cost. Once the model cost has been taken into account. For sure, this is not come easy. So all these benefits as a cost, and the cost is model and simulator development. The literature doesn't provide quantitative limits or ideas on how good the model needs to be. So it's more qualitative description of the model reliability. For example, in particular, this reference tells us that the model should be at least good enough for me to say that I'm comfortable to use it, to take a decision and send people to flight with my model. That I think it's a good rule, but it's a qualitative one. The We for sure know that simulation is used very much in training. The use is slightly different than a certification model. Typically, training can rely on a set of rules already defined, the FSTDH, that provides even a specific test, a specific bunch of tests, some rules that the model should respect. Boundaries on which the model should stay to reproduce the flight test data. But the certification simulator is a bit different because it comes earlier than the simulator, than the training device, and also the need of extrapolation capabilities is stronger on the certification simulator. This is because we need to use the certification simulator especially to extrapolate, so to test conditions that have not been tested before and for which we don't have a predefined benchmark provided by flight testing. The simulation, from our point of view, to be useful, simulation for certification in this respect, not for training, should have a strong emphasis, should give a strong importance to physical behavior. So if we want to extrapolate, we should be able to keep the physical meaning of all the parameters that we are even tuning to match the flight test data. And from a second point, if we move to the simulator, we should provide adequate cues to the pilot. From our experience, for example, power off landing, the model might be good, but the pilot might complain about the feasibility of the maneuver due to lack of cueing from the hardware more than from the reliability of the model or of the model quality. Our challenging view is to try to cut down current certification flights or flights used to support certification by half in 10 years. Moving to the second section, the second section is our experience so far. So I'll present two examples. One is the power of landing of the 189, in which the means of compliance was simulation. Sorry. This is basically a full example of certification by simulation, in which flight testing was used to support simulation. And another one that I will explain you later, the details of which I will explain you later. Civil aircraft have a requirement to land safely, even if two engines have a failure. And the paragraphs explaining these requirements are those listed in this couple of lines. So the 75 and 79 concern landing at A, so without after an engine loss, while 143 is about controllability in landing. The power off landing maneuver means that when we lose two engines in a flight environment, we need to demonstrate that the aircraft is still capable to land safely and to perform the auto-rotation, entry in auto-rotation, and then the touchdown without engines. This is a sketch of the power off landing maneuver. So in the first condition, one, we have the normal flight. Then we have the failure of the engine, of both engines. So the pilot needs to lower collective, compensate for pedal, and then with pedal and then train auto rotation, reach a stabilized condition as specified in R, explained in 2.2. Then close to the ground at a certain height from the ground, about 200 foot, perform a cyclic flare by pulling cyclic, gaining angle of attack and so lift, and reducing both the vertical speed and the horizontal speed of the helicopter. And then finalize the landing by leveling off and compensating the loss of lift produced by angle of attack by increasing the collective. And then touchdown. This is a very complex maneuvers because the pilots need to quickly, in an emergency situation, assess the distance from the ground. And respect the constraint imposed by the flight manual on this maneuver. The previous experience, we typically performed a partial validation in flight through just the cyclic flare. With the 139, we were asked from the American certification agency to perform a real touchdown. We performed that on the 139, but a real touchdown is always some risks. It's always some risk. So we decided in 2014 with the 189 to go for, with the support of the European certification agency, with a simulated maneuver. I will give you just a brief introduction to the helicopter we used to perform this activity. The 8 to 9 ton helicopter 189 used for offshore scenarios, VIP transport and search and rescue. I'll go with some details on the simulation approach we used. It was the first time for us to perform this kind of maneuvers. What we needed again was the simulator facility, the mathematical model compared against the flight data, at least in the portion for which flight data were available, and the green light from the certification authority. We perform this in our fixed base simulator that you can see in the picture on the right. It features a 139 cabin and emulated displays. But the section, the portion that can be tuned or changed according to the aircraft that we want to represent are basically the model and the displays. Simulated model for the FCS and trial model for the per aircraft characteristics. In order to provide this input to the simulation, we performed some simulation activities. So partially the maneuver was performed in flight. So the cyclic flare with the one engine idle was performed in flight. Then the cyclic flare is not representative when for the portion in which the pilot pulls the collective, because the engine comes in to provide power. So the last portion is cannot be reproduced in flight, and that was done in simulation. The main comment was that as I told before, not only the model needs to be taken care of, but also the simulator. So the pilot perceived a higher workload and difficulty in section of the ground altitude on the offset from the ground that make more difficult for him to optimize and to time correctly the pull of the collective and the moment to perform the flap. So that's why I was putting emphasis on also the hardware that provides the cues to the simulator, to the pilot, because sometimes lack of cueing is perceived as a lack in modeling, but for sure the pilot can see the overall results, cannot split the two. With that model, and after the okay with the other that came to test the performance of the model in our simulator, we performed the simulator in the maneuver in the simulator, and prepared the flight test manual section using the results coming from the simulator test campaign and the experience of the flight test department. The approach was this time accepted also by FAA with respect to what was requested for the 139 back in 2004. We were not asked to perform a real touchdown this time. Going to the second example, as I was talking before, explaining before, that this was a true certification by simulation. So the means of compliance was totally simulation with support from flight test to provide validation data. While the example I'm presenting now, it's the other way around, basically. So this is a CATE simulation in which the certification compliance is still done through flight testing, but simulation in our in this example provided help to reduce the flight and to give the crew confidence in their on-field performance of the tests. So what is a CATE? At least this is the definition coming from the RoCS, that are a document that explain the minimum safety requirements and procedure to fulfill those requirements for transport aircraft. CATE means an aircraft that is certified. CATE means that it can land or fly away safely after one engine failure. The example I talked to you before was a two-engine failure. This is the single engine failure for a double engine helicopter. This is one picture, for example, of a takeoff procedure for the 189 in the scenario of a confined area heliport that you can see at the bottom of the picture from when the helicopter starts the maneuver of takeoff. So the helicopter starts the maneuver of taking off. It backups from a minimum, in this particular scenario, from a minimum of 50 feet to a maximum of 2,250 feet. Then goes pitch down and flies away. If the pilot performs the maneuver as in the flight manual, even if we have an engine failure at the peak of here, for example, at this TDP, the aircraft can land or fly away safely. So if the engine failure happens before the TDP, that is the takeoff decision point, the pilot will bring the helicopter down to touchdown. If it happens at or after, it can fly away. So all these maneuvers are typically performed, are typically described in the flight manual through charts, function of weight and ambient conditions. So the amount of flight testing behind a certification of this kind is big, especially because you have to move in different different area of the world in order to get the correct ambient conditions. And also the rehearsal is performed in flight if the flight test department is not provided with a good and reliable predefined performance of the rotorcraft. So the idea was for this particular certification of the last engine we put on the 189 was to give more support to the certification process through simulation, and in order to again reduce cost and time and risk of performing the flight test activity. Again, the focus is again on model validation, physics model validation. So again, we need to understand what's happening in order to then be able to extrapolate. This was, for example, the most important thing of this model to simulate the engine of the one engine failure is to capture the time history of power after the failure. For example, here we see the time history of power during the failure happens here, and so we lose power, and then the other engine comes in order to partially compensate. So for sure, we need to able to reproduce this performance, able to reproduce the available power to the helicopter, but also the necessary power. So for sure, it's the first step was model improvement. So this is, for example, the tuning, the result of the tuning of the time history of torque after the engine failure and after we started the activity. Another section that's for sure important is the low speed interference. All these maneuvers happen in low speed and are given to the pilot in terms of speed in the flight manual, of speed and pitch attitude. So both need to be captured correctly. And weight interference on the tailplane plays a major part in matching both the speed and the pitch attitude. After the tuning, we were happy with the matching. The picture shows the parameters that are important for this particular maneuver. That is pitch attitude in the middle, vertical speed. After the failure, there is a loss of, for sure, of altitude, increase of vertical speed, and then fly away. Also, the ground speed is important because the pilot needs to track both the pitch attitude and the ground speed in this condition to perform the maneuver properly as it is certified. So we used the model. We provided the crew charts to reduce flight testing when they went on field to perform the flight. For example, here we see one example of the charts we provided. So the 8 loss, that is the major parameter that is important in this maneuver. 8 loss after the engine failure as function of gross weight and ambient conditions. So again, the idea is to define a maneuver in which we can increase as much as possible the gross weight for which we can certify the aircraft and also covering as much as possible the ambient conditions that we want where we ask a certification to the certification agency for that maneuver. So these are the two examples that I wanted to discuss in more details. Then we had some other activities. For example, for sure, rehearsal of this kind of maneuvers in scenarios that are difficult to attain. We did that. So rehearsal of Cathay maneuver for offshore landing. So landing on the offshore platform for the 139, but also for the 189, same scenario. And then also the power off landing was performed for other aircraft, 139, 169. For the 169, we get the okay also to include the to demonstrate by simulation the quick load release. So to extend the test, we performed in flight with a single drop of an external load to extend it in various conditions by simulations. Again, the power off landing certification for the tracker and for the koala in high altitude. And again, offshore scenarios for the 189 for safe ditching simulations, in which for sure is not a scenario that we can test through complete flight testing. So I have explained our view and our experience so far. The first step we took to try to get that challenging target of reducing so much the flight test activity in 10 years was to get the opportunity to launch the RoCS project, certification by simulation, in the environment of the joint undertaking for fast rotorcraft. So we launched this project that is called the RoCS, Rotorcraft Certification by Simulation. It covers not only helicopters, but not only tilt rotors or fast rotorcraft in general, but also helicopters. I won't go in details because some of the presentation that will follow this one will give some details, more details on the RoCS project. But basically, the target is to expand on what we did for the certification by simulation so far. The example I presented are basically customized, so there are no general rule that we follow. It's basically validation is an acceptance from the certification authority case by case. So the idea was to launch this project in order to try to make a first step on standardizing the application of simulation in future certification in Europe. The main objectives are try to answer these questions. So can any certification paragraph be substituted or not, or are special cases? There are special cases for some paragraphs and some others cannot be substituted. The second one is again a model. How good the model needs to be used in certification rather than training. And again, how good the simulator needs to be to provide the pilot with the proper cues that allows him to perform maneuvers that typically are failure in case of certification by simulation approach. And basically, yeah, this was my last slide. If you have any questions. Okay.